Okay, so the first problem is to use the shell method to find the volume of the solid generated by revolving the region bounded by the given curves and lines about the y-axis. So the first equation you have is y equals 8 minus x squared. The second equation is going to be y equals x squared, and the third one is going to be x equals 0. So before we do this, we have to find the f of x and g of x. So between these two, the biggest one is going to be 8 minus x of x. X squared, which is going to be the f of x. So f of x is going to be 8 minus x squared, and then the g of x, which is a smaller equation, which will be the x squared. So once we do that, we have to find the x value. So when we do that, we're supposed to do 8 minus x of x, x squared equals x squared. So what we want to do is just bring this x squared to this side right here. Then you will have 2x squared equals 8. Divide both of them by 2. You have x squared equals 4, which will then make x equal to plus or minus 2. So basically, the a would then be -2 for the lower bound, and b, which would be +2 for the upper bound. So then you make the integral for the shell method, which will be the integral, have 2 on the upper bound, -2 on the lower bound. Then you do pi, because you're trying to find the volume, the absolute value of the first equation, which is 8 minus x squared minus x squared, all inside the absolute value d of x. And then from there, you can basically simplify the equation. So you have, again, 2 on the upper bound, -2 on the lower bound. You have the pi, and then the absolute value of the first equation. And then from this part right here, you can simplify that to being x to the 4th. So minus x to the 4th, all inside the absolute value, d of x. Then for the next step, you want to get rid of the absolute value. So by doing that, you just want to add another set of parentheses. So instead of 1, it's going to be 2 parentheses, and then the first and second equation that you were using. Minus x to the 4th, d of x. And then since you've already done that, you can basically get rid of the parentheses, but also take the pi and take it outside of the integral. So then it'll be pi, the integral of minus x squared, square that, minus x to the 4th, d of x. Basically simplify that again to making it into 2 integrals. So pi, and make sure you have your parentheses too. squared dx minus, and then bring it on this side, the integral of x to the fourth dx. So from here, you basically want to solve the first equation, which is the 8 minus x squared. So 8 minus x squared, you square that, which will then be equal to 8 squared is 64. Basically, 8 times 2 is 16, which would be 16x squared. So it's minus 16x squared. And x squared is going to be plus x to the fourth. And then from there, you basically want to take the the integral for the 64. So be 64 d of x, which would be 256. The next part would be taking the integral of 16x squared. (16x squared d of x) should be 256 over 3. And finally, take the integral of x to the fourth. X to the fourth should be equal, d of x, which is equal to 64 over 5. Okay, so after you've done all this, you basically want to join them together. The 256 over 3, and the 64 over 5. Should be 256 minus the 256 over 3 plus 64 over 5 equals, you want to basically make them to the common denominators, which would be 15. So multiply this one by 5, the top by 5, be 256 times 5 over 15 plus multiply the 64 by 3, 64 times 3 over 15, and then multiply the 256 by 15 to be minus 256 times 15. So you do all that, you'll get 2752 over 15. So you get that for the first part. From there, you bring it back to the regular equation with pi. So then it'll be pi, get this answer right here, 2752 over 15 minus the x to the fourth answer, which is 64 over 5. 64 over 5, which should then be equal to 512 pi over 3 once you simplify it. And then that would be the volume of these equations right here.